So, my talk is on patient data and where to find it. We're going to sort of go over the differences between sort of enterprise and clinical environments and what the differences are. I'll also talk about various different medical protocols and technology that's specific to healthcare, and interdisperse between that some security issues that these suffer from, and also some relatively safe things you can do to extract some juicy patient data. And then finally, just go over a few existing tools that are out there, and if there's any time, some questions. First of all, my name is Stuart Kurutac. I'm a senior consultant. I've sort of worked my way up through IT over 16 years, starting off as a service desk analyst and then onto various roles, and then basically brute forced my way into becoming a pen tester. And over the past 4 years, on and off, been looking at healthcare technologies and stuff and researching that. So a lot of this is going to relate to what we would call sort of network penetration tests. So when you're looking at assets on the inside of a network. So when we're looking at sort of standard enterprise networks, the kind of things that you're going to see in there are going to be, desktops, laptops, servers, like network switches, firewalls, and some mobile devices. And that's generally what you're going to see across the board. But when you go to, say, like a hospital or any sort of healthcare environment, there are going to be additional things in there, such as like medical devices. So like think, patient monitors, infusion pumps. There's going to be labs in there, pharmacies, there's like ambulance sort of networks for communications, and then other healthcare specific systems that deal with like patient data. So there's a vast amount of additional technology that is completely different to your standard enterprise devices. And a lot of the tools that you use as a pen tester, they are like really well fine-tuned to what you'd expect to see in enterprise networks. So you're not going to necessarily pick up on a lot of these other things. And really, in a live environment, you don't want to be causing any disruption in those environments because they could be quite old and could get knocked over by the slightest of scans and things like that. So generally, want to be careful. So when you're doing, say, your normal network pen test in an enterprise environment, as a standard penetration test, what you're trying to do is find as many vulnerabilities as possible, and you assign, a risk rating on that, a technical risk rating, depending on, how severe it is, how easy it is to exploit, what kind of impact is. When you are, say, doing this similar test in a healthcare environment, you maybe want to shift your focus. So the ultimate thing that you're thinking about is what can affect patient safety. So it might not be that, enterprise software that's got a vulnerability that's got a CVSS scoring of like 9.8. It could be something like seemingly a lot less severe than that, but could cause, huge impact across the board. Sort of on a flip reverse of that, some researchers from McAfee did found like a CVSS scoring, so like a common vulnerability scoring system score of an infusion pump which got 9.8, so they could like remotely control this thing and deliver a deadly dose of whatever was in there. You look at the NHS website for that and their own sort of impact scoring on that, and they put it down as a low. So technical risk doesn't always assign or relate to clinical risk. So that's just something to be aware of. And the reverse is also true as well. So some protocols, some of these are technically standards, but these are things that you'll see in healthcare environments. So we've got HL7v2, so that's developed by an organisation called Health Level 7, and that's a clinical messaging standard. It's to do with sending all sorts of messages to do with the administration of like patient care and things like that. Then we've got DICOM, which is a medical imaging standard. So, you think if you ever go for an X-ray or a CT scan, MRI, whatever, the images get something from that will be using DICOM, probably. We've got next one, FHIR, which is Fast Healthcare Interoperability Resources. This is also developed by Health Level 7, and it is supposedly being designed as a replacement for HL7v2. And it uses different technology. And then finally here we've got this LIS02-A and POC1A2. And this is primarily used in labs. So like if you ever get blood sent off to somewhere, that's what's going to be in there. And they're very, in its structure, it's really similar to HL7v2. And it also has the same sort of security issues. So I won't go into that in this talk, but just to be aware of it because it's used a lot. So, a little overview of H7v2. I said it's a clinical messaging system. It's sent over TCP. It uses this minimum layer low protocol, which is basically a bit of a wrapper that goes around the message body. There are different message types. So these can be, for example, there's like ADT, ORU. These denote what types of clinical message they are. So I'll go on to that in a sec. It's an old protocol. It's been around since the 80s. But according to HL7's website, it's still in use in like 95% of US healthcare facilities. It's also not typically sent on a standard port, even though there is an IANA assigned one, so that would be 2575. There's no hard and fast rule about sticking it on any port you want, as with most things, but this is more common with HL7. It can be on anything, so it makes it a bit more difficult to sort of identify on a network. So I said we've got the message types. We've got two of the common ones there, ADT, which is for admit, discharge, transfer, which you can imagine is for messages where you admit patients, discharge them and transfer them. Then you've got these observation result messages, which are also pretty common. So that's when you are sending a result from like a lab test or something like that. These are usually just sort of, they're one-way communication. So you're sending data to somewhere and that endpoint is then receiving it, with the exception of query messages, which is the only type where you can extract data from somewhere. But as of, I think it's 2.7, version 2.7, that's been removed. So this is like an abstract representation of what a message, HL7v2 message would look like. So they're made up of segments of text, and each segment is just like, say, imagine like a line of text on like Notepad or something. And they all start off with sort of three characters, and they denote what that segment is about. So MSH is message header, and that is on every single one. And then below that, you see we've got PID, which is patient identification. And each segment is made up, consists of what are called fields, and these are separated by pipes, and they contain all sorts of stuff like this. This is what a typical HL7 message look like. So you can see we've got the MSH. It's a bit small, so apologies if you can't see that. That first line there is MSH, and then you've got those the four characters there, they're escape characters, and those ones are always in every single message. Then the fields from there are like the sending application, the sending facility, then it's the receiving application, the receiving facility, then date, and then as you can see, it kind of drops off the end here. So that's the ADT, that's the message type AO1, which is a patient admission type of message. Then the H7 interface that you're sending that to will generally send this example response below, which is an acknowledgement. So again, it's got obviously the sending application and facility were the receiving ones at the top, and so on and so forth. So this is a Wireshark screenshot, so it's a network packet capture for those that don't know. It's basically what the traffic looks like on the network. So they've intercepted a request here, and luckily Wireshark has a HL7 filter on there. So you tap that in and it shows you this whole message. So when I said before about MLLP, that minimum lower layer protocol, it's basically those bits highlighted in red. So it's got a start byte, 0B, and then an end and a carriage return, which is 1C0D. And that's all it is. And then the rest of it is just clear text in the middle. And if you see on the left-hand pane, that's all the different segments there listed. So you've got MSH, EVM, which is event type, PID, patient identification, next of kin, and then at the bottom you can see there's AL1s, which are allergy information. Okay. And then that's just highlighting the message header on its own there. And then this is just the acknowledgement that you'll see again with the MLLP bytes highlighted in red. So what are some issues with that? Well, it's sent in clear text. In fact, the standard doesn't even facilitate encryption. It basically says in it, that's your problem, you need to sort it out, kind of thing. There's no authentication, so if you're on a network, you manage to identify one of these things, you can just send it a message. Don't, by the way, that's really bad. And with those two sort of things combined, it's really susceptible to man-in-the-middle attacks. Research by, I think, Dallas from the SANS Institute, he did this a while ago. He shows it in detail about, conducting that attack. And then later on at DEFCON one year, some researchers took it a bit further, and they, in real time, intercepted and changed these messages on the fly. So, really bad. There's no way of sort of detecting these man-in-the-middle attacks. So what can you do safely if you're ever in that environment? So this largely boils down to being on a server or a host. You just doing a file search. So if you're doing an internal network pen test and you find an open file share or something like that, commonly people will search for users, passwords, things like that. In a healthcare environment, search for the MSH pipe and then the escape characters. Maybe you'll bring back a load of files that have been sent in logs and things like that, because those log files may contain these messages, and in some HL7 messages, there will be an OBX segment, which is an observation type segment. And in there, quite sometimes you can have base 64 encoded string of, say, a doctor's letter or a note about, a certain patient. And this is something that we've seen internally on an engagement where we found a share with those in. Decoded the base 64, and sure enough, it's really sensitive, patient information. It's get rid, tell them straight away. On sort of firewall reviews, if anybody's ever done one of those, they can be pretty boring, but very, very necessary. One of the things that you might call out is administrative or clear text services. So things like HTTP, Telnet, FTP. Have a search for anything that's either on port 2575 or HL7, and you can say, right, you've got some clear text. This is also clear text in there. If you've compromised the host or managed to get on one somehow, check for the running services and see if you can see a HL7 interface configured on there. You're unlikely to find it by doing an Nmap scan, just because it can't be, most of the time, it's never assigned to a specific port. And Nmap's not clever enough to identify it otherwise. You can... and also the disruption that you could possibly cause to it as well. So just not worth it. So one other thing to do, and if you're ever in a situation where you're doing a test like this, is do some POCs, so proof of concepts on your own machine to demonstrate the issue, because these are the extraction of patient data is a really severe issue in the hospital or any facility like that. So you can do your ARP spoofing attached to show you man-in-the-middle attacks, and you can do that really easily by using, for anyone who's got any experience in coding with Python, use a HL7 APY is a Python module that allows you to do that. So lots of examples of how you can set it up. So, really easy to do, really highly recommend you have a play around with it and have these as, a ready to go sort of issue that you could use in those situations. DICOM. So DICOM is a standard as well. DICOM files would be the sort of images that you get from MRI machines, things like that. But it's not just the imaging. they have a load of information in there, a load of metadata in there. And these are like data sets, which are basically a huge amount of data that's separated into like individual elements called data tags. The standard also describes a network protocol and an API as well. So it's not just about the construction of the file itself, it's also gives you details and describes how to send those files across the network. So this is an example of a DICOM image. As you can see, some in that top right-hand corner there is a patient ID, and that's the patient name there. So this is just an example of what's displayed on this particular web viewer for this DICOM server. And in the same DICOM server, this is Orthanc, by the way, it's open source. This also displays in one of the areas of the application as well. So as you can see, you've got these numbers on the left-hand side. Is it left? Yeah, if you're looking at it, it's left. So these numbers here, they're hex representations of the data tags. So the first four are the data tag group, and then the last four are the data tag element. And the group sort of signifies what it is. So 0010 at the bottom are all sort of patient related. As you can see, there's the patient name there and a patient ID. There's loads more than this, by the way. If you just search like DICOM data tags, there's like a library, a website on there. You can just search through them all. So here's just a snapshot of this script, some scripts that I've got. So I search for all tags containing the word patient. That's not all of them. That is about a third, maybe a quarter of them. But just to give you an idea, on the right-hand side, there's all tags that are to do with physicians. So what's really worthwhile having a look at is if you've ever had a scan, ask for your scans. And when they get sent to you, just look at them in a DICOM viewer, and there's loads of free ones out there. And there's tons of information in there. Like I got mine, and it had loads of details about me, obviously, but it also had details about my the surgeon, the doctor that ordered them, the person that took the images. There was also the IP address of the workstation it was on, the software name and version of that as well. So, I mean, you could technically build a 2 or 3 issue report for this by just getting your DICOM images. Some of the security issues with these then. Typically, the common ports that you see are 104 and 11112. These are clear text ones. There's a couple of other ones, so 2762 is sent over TLS. There's weak peer authentication. So unlike with HL7, there is actually a way to restrict access to DICOM servers or PACS, which is Picture Archiving Communication Systems. Basically, same thing, really. One way to restrict access is by IP, but again, you can spoof that. Another one is by using application entity titles, or AETs, and that's basically just the name that you give to the server. There is a 16-character limit on those in the standard, so you could potentially brute force those as well. And then there's been a few examples of injection where you put malicious payloads into those data tags. And one of the more interesting things are that the DICOM file can be used to create a polyglot, which is basically a file that is multiple different types of files in one. There's this 128-bit byte preamble to start, which is used to be able to tell non-DICOM systems that it's an image and that they can see it. So you could put a DICOM image in like Paint or something, and you'll still see the image, just not the metadata. And one researcher named this their version of this Pedicom. So they use that preamble to point to different data tags that were essentially an executable. So it was still a DICOM file, but you change the extension or just run it directly from the command line and it would be a Windows executable. So pretty nasty. This, as you can see, is just 2 screenshots of Shodan. Search for DICOM on there. They're taken a week apart. So not a huge, massive increase, but you can see there's currently 5,500 exposed endpoints on the internet. 2,500 of those are using the well-known port 11112, which is clear text, and then nearly a couple thousand more 104. 442, third one down incidentally, is the default port for Authanc, the open source one. So depending on which version it's running, is susceptible to some pretty nasty vulnerabilities. So what are some safe things you could do? Again, file search, but you could search for the extension, which is .dcm, but you might get some false positives because of some Windows files, depending if it is a Windows host. So I typically would search for the SOP UID, so that's a service object pair. It's basically just a numerical ID to tell the standard what type of file it is and how it was stored. Again, with firewall reviews, look for DICOM, look for ports 104, 1112. There's clear text. That's an issue. The C commands are something that you can do fairly safely with these. So this is the network protocol. Some of the main ones would be like C echo, which is basically like ping. It's just to sort of say, send a C echo request to a server, and he goes, yeah, I'm here. Using DICOM networking protocol, there's C find, C get. So find is like searching for a file, get is retrieving it. There's also store. And these can be protected on an individual basis. So you could say that you're restricting access using AETs or IPs on, say, the C store, but not on C echo. So anyone can send C echo, but only certain ones can do C store or whatever. The one. So yeah, just an example of me doing a search on my virtual hospital for the SOP ID. Well, part of the SOP ID, and that's returning all the DICOM images there. And this is Python, using a Python module called PyNet DICOM. They have an inbuilt SCU, so that's service class user. That's basically a client. That's using the find SCU, just pointing it at in my lab, this IP address, the port, the query level, which is patient. If you set that to series, you'll probably get more. And then a patient name of star. So as you can imagine, you send that off and it gets all these hits. Now I've seen this quite a lot. I've not done loads and loads of healthcare pen tests, but on each one I found it on them. So worth a shot if you're doing that, but just don't do star or Control-C straight away because everything. Now, the amount of information it's retrieving here, that's hard-coded in the PyNet DICOM module find SCU. You can change that if you just write your own, and they've got examples of how to do it. So you can include all that other juicy data like, system, software version, blah, blah, blah. If it's on, if it's been set in the file, it will return it. So... And then, some other things that you can do in there is, again, have a look at these like open source software, figure out how to do POCs, like proof of concepts on that, with the injection types and using PyDICOM, PyNet DICOM, and Authanc. So Authanc is the open source server. So with the types of injection, you do things like XSS, which is something that found on Authanc previously. This has been fixed now. Obviously, this is from quite a while ago. And this is only in the web viewer module of it. So, it depends on what's available at the time. But how you do that is quite simply, as you can see, under patient ID, just got the simple payload there and that executed. So, worth doing things like that as a proof of concept. And then, again, that's just that being fired off. So FHIR, Fast Healthcare Interoperability Resources, this is sent over using HTTP and HTTPS. It's got different formats using JSON XML. It's basically just an API. So this is still in development really, so you probably won't see it much. And this is just an example of what a patient resource might look like. So at the top there, I don't know if you can see that first line is resource type and then patient. So that could be like anything like, doctor scans, whatever, according to the JSON. So again, with this, sort of repeat myself, but file search, because these things can get logged. So maybe search for strings like resource type and patient, and you can probably find a bunch of that. And you want to follow your standard API testing methodology for this. So one bit of research that was done a few years ago by Alyssa Knight was looking at a FHIR API endpoint for a HIR health information exchange thing, so one of these big things in America. And typically it'd been set up, all good, authentication required, but there's no segregation in there at all. So once you've authenticated, you could access any patient data in there. And it was self-registered as well, so, basically open. There's one thing to mention here, which is the capability statement, which is open to everyone by design, and it's basically just a big metadata endpoint which lists out everything about that FHIR interface. So, this is the file search. And this here is the capability statement of OpenMRS that I've got set up in the lab. So I've just extracted a few bits in there. What you might not be able to see is it tells you the server software, the version, what version of FHIR it is, and what resources are available on there. So this is by design to help people be able to create APIs, but it's still a bit of information leakage. So, worth having a look at. And that endpoint is metadata, always metadata. Okay, not too bad for time. So moving on to sort of healthcare technologies that you might see in there, there's the EPR, which is a electronic patient record, or it could be the EHR, electronic health record, or EMR, electronic medical record, basically the same things. There are some nuances between them, but they're essentially where all the patient data will be. My personal favorite is the integration or interface engine, which facilitates interoperability. There's a long-standing issue in healthcare organizations where there's loads and loads of devices. None of them want to talk to each other. So someone came up with one of these, basically allows you to have an interface, receiving interface. You can do some magic in between and it spits out, a different message that's compatible with the receiving device. And you've got LIS, so it's a laboratory information system. There's lots of ISs as well. So there's like a RIS, which is radiology information system, a HIS, hospital information system, or HIMSS, hospital information management system. Basically overarching systems for each part of the hospital in there. And then obviously you've got medical devices. So these are point of care devices, like I mentioned before, patient monitors and whatnot. So with EPRs, like I said, these are the main system where patient data is held. There could be multiple of these in hospitals. I guarantee you they're not going to want you to test against these. Certainly not in a live environment. You never should. They're so complicated. There's lots going on with them. So there's the potential for inadvertently changing healthcare data in there is just too great. They're so complicated. They've been attributed to burnout in doctors. Something like, I don't know, one statistic a while ago was tons of people are quitting just because of the implementation. But again, there's an open source versions of it. I'm using images of Open EMR here, just not because it's inherently rubbish or anything, but because it is the easiest to set up that I've come across. It just get it running, guide you through it, and it pretty much never fails. Once you're logged in, it's kind of what it would look like. Not the prettiest of things, but you get the idea. There's, menus in there, menus and menus. That's one of the smallest menus as well. So you can imagine how sort of complex they are. No. So, what do you do with these? Well, essentially you just apply your application methodologies to them. Always be thinking about how you're extracting patient data and how you'd impact patient safety. Never be thinking about I want to get the, the admin or whatever. I mean, still a good goal to have, but you might not need admin to do this. You could have a low level user and just absolutely rinse all the data out of it. And that's way worse than striving to get admin with the same results, basically. With the integration engine, I said it sort of facilitates communication with lots of different devices. It's highly configurable, so you can put Java in there and make it do all sorts of mad things. And it's also used to automate workflow, so it could be multiple steps involved. Now, Mirth Connect is an open source one. Again, so there's lots of open source options for everyone to go out and have a little play around with these things. it's written in Java. There's a Java client that you need to interact with it with all its full capabilities. It does have like a web interface, but there's very few functions that you can do on that. So if you logged in to one of these, default configuration doesn't have multi-factor authentication or anything like that. There is facility to do that with it though. And I've seen these in networks where it's just admin. So, these are things you need to look for. So this is like the dashboard, and it shows you what's running on there. And all these things here are called channels. So if you go into the channels bit, then these are all the things that you configure to do all the magic. And this one I've highlighted here. This is something I configured after going on a search online just to see if I could get, something working. And I came across a comment which was, oh yeah, we just use it to like directly input to the backend, like the database of the EHR. So, you could have all the security you want on your EHR. It's got, RBAC, MFA, lockdown and all this, but then you've got like this interface engine that's just like admin, and it gives you effectively the same access. So this channel is configured with a source for a TCP listener. It's got an LP. Its max connections there, 10. That's default, so you could probably just DOS it really easily as well. And then on the destination tab on there, as you can see, it's a database writer going straight into the EMR database, and you could do all sorts with that. It's got the username, password there, and just use your imagination, go wild. Obviously not in a live environment. So this is, with the integration engine, it's just to highlight how key this thing is, and doesn't seem to get as much exposure in media and things. So it's essentially an allowed man in the middle. It's just it could be a wink link, because it could be like loads and loads of channels in there that are going off all different systems. You can have loads of patient data going through it, and it's just like, this is one. Have a go at that. Tooling that's out there, not a lot. MedAudit, HL7 Discovery, and Fuzzer tool. I've never actually got it working, but give it a go. Then there's Topirix, which is kind of like Wireshark with the HL7 and DICOM filters in there. Smart HL7, which is a suite of tools, standalone XEs that are Windows only. And then more recently, HL7 Magic, which was presented at DEF CON last year, I think. It's a Burp Suite extension, which allows you to do that man in the middle for HL7 interfaces. Not much else. So, as you might have noticed, there's a few scripts there that I've all shoved into, it's a bunch of my scripts that I've shoved into one tool. I was hoping to do like a bit of a presentation on that as well, but my house move has gone on too long, and all my stuff has been packed away, so I've not been able to finish that. But essentially, Plague is one that I've been developing and will hope to release soon. Any offers of collaborating with that are always welcome. And this is my essential list of reading. I can send that out to everybody if you like. That's basically everything that I've talked about there, with lots of detail, juicy detail in there. And specifically, my favourite one at the bottom is a DNA malware one. Essentially, researchers from Washington University injected a malicious payload in a DNA strand, shoved it into their lab environment, and just the sequencer read it and executed the payload, and it compromised it with that. So cool, man, well cool. Obviously, they had put it under optimal conditions, so they introduced a vulnerability, but the idea, just the concept of it was wow, that's amazing. So anyway, that's it. Any questions? Have we got time for questions? No? Yeah? Maybe? Okay. Maybe one or two? Yeah. Okay. Cool. Oh, yeah. Go on then.
It's pretty clear some of the protocols there will be designed by security in mind.
Yeah.
Do you think is there a need for kind of a PCI-S standard for healthcare?
So they're heavily regulated anyway. So I think HIPAA in the US, none of that should be on the network, but it is. It's one of the heaviest regulated industries but enforcing that regulation is the issue. Like, every time you just read the healthcare sort of media stuff, and you'll see, like, especially in the US, like, it's 2 or 3 a week being ransomwared, and it's like, well, if they're HIPAA compliant, like, is it the regulation, or is it the enforcement of the regulation that's the issue? And I'd say it's the latter, definitely. Yeah, and like over in like NHS in England as well, like they've got DCB 0129, DCB 0160, they got all the other stuff as well that goes with it. But, they've been like popped quite a few times as well. So it's the enforcement of it. Absolutely. Like, the rules are there, so that stuff should be protected, but yeah.
Yeah, those protocols, are they mainly just using US, or what do we use in like Britain or Ireland?
Sorry, say that the protocols.
Yeah, like
yeah, they're in use everywhere. Yeah, so everywhere? Yeah. So I was only saying like 90% of US hospitals because that's what there's on the website. But yeah, they're over in all over really. Yeah, they're like the main sort of like protocols that are used basically everywhere. Yeah. Anybody else? Hello.
How does anybody who works in security in the healthcare service get any sleep?
Yeah, they don't. Like, there's like loads of burnout and people are just like stressing all the time. It's like awful, right? Yeah, but it's what can you do? You've got to hope that people just don't pop this stuff, because the people who do are like proper low dirty. Of all the criminals, it's the dirtiest one to do. Like, there's some of the things that I've read over the years, like, really bad. I won't go into it because it's proper nasty, but yeah. Sorry, yeah.
I shouldn't say this, but I work for a company that takes DICOMs. Our first job is to scrub.
Yeah.
So we take the data and scrub the metadata, delete that, and then operate on the data with the tags.
Yeah. Perfect. Yeah. So what you want to be doing, like,
if we didn't do it.
Well, yeah, if you didn't do it, yeah. But like, I can, like, when I ordered my images, it was from the hospital, and it was, it was sent second class, no signature needed. Yeah. On a disk with no encryption.
Because we get them for secondary processing for medical procedures.
Right, yeah. So you're obligated, right? You're part of the supply chain. You're obligated to do that. If you get in trouble, it's bad. But there's lots of other like companies in that supply chain that, according to the media and my echo chamber on the internet, just don't do it. Mm-hmm. Right? Yeah. Anybody else? Awesome. Thank you very much then.